Okay, guys. So, lesson. You'll notice I call this lesson 3.2.1. And if you flip and glance, you'll notice that tomorrow I'm going to do lesson 3.2.2. So, all I've done is I've taken lesson 3.2 and broken it over to 2 days. I'm not necessarily saying we need to break it over into 2 days. This is technically Algebra 1 review. However, it's important. Okay, we use this within other algebra type problems and whatnot. But our focus today, our one and only focus is substitution. Okay, so we are going to purely focus on the substitution method. Tomorrow, we will purely focus on the elimination method. So some of you guys are going to hate today, love tomorrow, or you'll love today and hate tomorrow, depending on which type of problem you prefer. To me, it kind of depends on how the problems are set up as to which I prefer. Some problems are better set up for substitution, some are better set up for elimination. But today, regardless of how it's set up, we're going to practice substitution. So, do you guys remember anything about substitution? Okay, we remember the word. Do we remember more than the word? How to work with it, or Kendra?
Usually you try to get one of the equations to something that equals y or something that equals x, and then plug that into the other equation.
Okay. So substitution usually works best if you have one equation that's already x equals or y equals, that you can then take and substitute into the other problem. Now, that's not necessarily true today. We're going to look at ones that aren't already that way. So as we look at example 1 here, 3x plus 4y equals 12, 2x plus y equals 10. Which equation would it be easier to solve and make either x equals or y equals? Okay, you guys are picking the second one. And why are we picking the second one? Okay, we already have y that has a coefficient of 1, yes? There's already a 1y, which makes our steps a little bit easier. So let's get y by itself here. To get y by itself, we want to move this positive 2x. How do we move positive 2x? Subtract 2x. If I subtract 2x on one side, subtract 2x on the other side, and so what does that equation become? Okay. Y equals negative 2x plus 10. Or honestly, if you prefer y equals 10 minus 2x, it's not a big deal today. Which one makes you happier, right? Okay. What do I do with that y equals negative 2x plus 10 now? Okay, we're going to take this what y equals and plug it in to the first equation. So we're going to use this first equation up here, and we're going to plug it in. Every place I see a y, I'm going to replace it with negative 2x plus 10. So my equation is 3x plus 4y equals 12. So that means in place of that y, what am I putting? Negative 2x plus 10. Does that sound familiar?
Yeah.
Or if it doesn't sound familiar, okay, does it make sense? Are you okay with what I've done? Because maybe you don't remember this from Algebra 1. Whatever, we're still going to do it. Okay, now you have an equation that has x in it. How do I solve?
Distribute.
Okay, we have a 4 that needs to distribute into these parentheses. So let's do that. So I have 3x plus, what's 4 times negative 2x? Okay, negative 8x, or I'm going to write minus 8x, plus 4 times 10, plus 40, equals 12. And now this gives me the opportunity to review our basic equation solving skills. What do I do next? Okay, combine like terms. 3x minus 8x. Negative 5x. Plus 40 equals 12. Now how do I solve for x?
Subtract 40.
Okay, you want to keep the x where it is. Move the other numbers away. So plus 40, we're going to subtract 40. Bless you.
Bless you.
Negative 5x equals 12 minus 40. Negative 28. And final step to solving. If it's negative 5 times x, divide by negative 5.
We can't do that.
You can.
I mean, 5.6.
Okay. Calculator is yielding 5.6. Yes?
Yeah.
Okay. Now, you could leave it a couple of different ways. You can say 5.6. The other option, could you leave it as 28 over 5? You can't now notice, I took the negatives off, right? Because what's a negative divided by a negative? Positive. So you could either express your answer to me as 28 fifths or as 5.6. Now, here's the deal. Am I done with this problem? No. What's that next step I have to do?
Yeah.
Take this answer and plug it into one of my equations to find y. Well, if we're going to take this and plug it in, which value is easier to use? The 5.6, isn't it? Okay, I'm not going to be silly about this. I'm going to, where is it easiest to plug this in at?
Would you plug it in for the 2x?
Okay, so 2x plus y equals 10 is a little bit easier. However, what's even a teeny bit easier than that, could we use this equation when we made it y equals? That's my recommendation, is that we use this equation right here to plug it in. So whichever of the original two equations you adjusted and made it x equals or y equals, use that. So y equals negative 2 times 5.6 plus 10. Well, negative 2 times 5.6, negative 11.2, and negative 11.2 plus 10, negative 1.2. You could have done it fractions. That's fine. I think it would have been, get negative 6/5 out of it. Okay. How should I express my final answer? Should I just say x is 5.6 and y is negative 1.2? Allie? Ordered pair. So 5.6 comma negative 1.2. Remember, it's always x, then y. Questions? Yes, David?
I forgot how you get the negative 5x of that.
Right here? Were you okay right here when I had negative 5x plus 40?
I was confused on how you got 5x.
Or are you talking up here? Okay, so up here, after I distributed, I had a 3x plus a negative 8x. And since these are already on the same side of the equation, I just put them together as is. Is that what you're asking?
Yeah.
Okay, yeah. We don't do, when they're already on the same, and this is something I've watched you guys do on quizzes and tests lately. If they're already on the same side of the equation, do whatever it says. Don't try and do the opposite when it's already together. Okay, that's a common mistake I've been seeing. So, okay? Anybody else? Okay. Let's try a couple more of these. Let's go ahead and try B as a practice. Of course, start working. Just stay a step ahead of me.
Yeah.
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 Now, how do you guys feel about G's and H's?
I don't like
you basically
that.
say it's a Y and an X.
Okay, if you don't like G's and H's, now, I'm going to be picky. Okay, I'm going to pick on you. He said we can basically call them Y and X.
That doesn't mean we have to call them Y.
But let's reverse that and say X and Y, because if I say G and H, then convert them to X and Y. Go alphabetical is what I'm saying here. Okay? And maybe that's what you would have done anyways.
G, X. Yeah.
Yes, G is X. That is my point. So G is X, H is Y. I just kind of wrote over mine. Kind of made it a mess there, but. Okay. So, with that in mind, which equation would you like to solve for X or Y?
What is the second one? No, first one. I want
Are you sure?
this.
I just asked that because you're being undecisive. So.
Well, you guys
You're sure, yeah.
Yeah, sure.
Okay, up here they're telling me Caden sure. So.
Yeah.
Okay. So the first one, what do you want to solve this for?
Yeah.
G or X.
Yeah, I would take this top one since it's 1G, which is like 1X, and solve it for X. Now, could you solve for any of the other variables? You can. You're just going to get more fractions along the way. So my recommendation is we take this X plus 3Y. Now, if it's X plus 3Y, what do? Subtract 3Y, right? And so then I'm going to have the equation X equals negative 3Y plus 5.
Yeah.
Kind of, yeah. And I know, I feel like some of you guys had already solved for Y on that. Don't feel like you always have to solve for Y. In substitution, go with whichever's easier. In this case, the X is going to be easier. Okay, so now what are you doing with that? Plug it in. So my other one is negative 2x. So that means negative 2 times negative 3y plus 5 is what I'm going to say. But yes. Okay, so negative 2 times x minus 4y equals negative 5. So that's how mine looks. Negative 2 times negative 3y plus 5, then minus 4y equals negative 5. Okay, what's my step?
Combine the longer. Yes. Distribute.
Distribute.
So it'd be 6Y.
Negative 2 times negative 3y is 6y. Negative 2 times 5?
Minus 10.
Minus 10.
Minus 4Y.
Carry down the minus 4y. And it still equals negative 5. Okay, what's next?
Combine the like terms.
Okay, so he's saying combine like terms because we have y's that are on the same side, yes?
Yeah.
How do we put those y's together?
It'd be. Yeah.
It's 6y minus 4y. Do what it says because they're already on the same side of the equal sign. 6y minus 4y is 2y. Still minus 10. Still equals negative 5. If it's 2y minus 10, add 10 to the other side. So then it's 2y equals, what's negative 5 plus 10? 5. 2y equals 5, so we're going to divide by 2. And y is
0.40.
okay, 5 halves or 2.5.
No, I'm like the other way around.
Now, good teaching point. If you got 0.4, what did you do?
Yeah, I flipped the 2 to 5.
You put it in your calculator upside down, didn't you? When you put something in your calculator, always do top divided by bottom. Don't. It's not necessarily bigger divided by smaller, smaller divided by bigger. It's numerator divided by denominator. Always. Okay. Am I done? Should I move on to the next problem? No. But some of you guys will do that on the quiz. So don't, right? Don't stop until you have both answers. Okay, what do we do with this y? Plug it in. Where's a good place to plug it in? Yeah. I mean, officially, you can go back to either of your original equations. That's fine. But I like to make life as easy as I can, so I like to use the one that I already have solved for, either x equals or y equals. So, x equals -3 times whatever y is, which is 2.5 plus 5. So, -3 times 2.5, negative 7.5. Negative 7.5 plus 5? Negative 2.5. Or negative 5 has, if you got it that way. What's the final answer I would like to see?
It'd be like, negative 2.5 and 2.5.
Negative 2.5, comma, positive 2.5. Okay. We're doing good?
Yeah.
You're going to ask me questions if you have them? Okay. Yes, I want to do the next one. I have my reasons.
At least this one is X.
Okay. Yes, this next one is x and y, so no confusion there. Negative 6x plus 2y equals 8. 2y equals 6x minus 2. Okay, name of the game is substitution, so which equation do you want to solve for which variable?
I said bottom line.
Oh,
Just divide everything by 2.
Yeah.
Divide. Oh my gosh. I don't like you guys.
Jaden, you can do the top one if you want.
No. I want to be like everyone else.
Okay, so valid point. Officially, you can solve either of these. Now, in both cases, I would say it'd be easier to solve for y, because you could add the 6x over, divide by 2, but it's even a little easier to just do that right here. So, exactly.
That one last step really counts.
Okay, so if we solve the bottom one for y, it's already at 2y equals, so divide by 2. And what is y equal to? 3x minus 1. That's not horrible, right? Okay, so now what? Plug it into the other equation. So, my other equation is negative 6x plus 2y equals 8. Every place I see a y, what am I replacing? 3x minus 1. Like all of our other problems, we're going to distribute. So, negative 6x plus 2 times 3x, 6x. 2 times minus 1, minus 2, equals 8. Next step.
Combine those two things.
Combine like terms. What is negative 6x plus 6x?
X. Just the X.
It's 0.
It's 0.
Oh my goodness.
If you want to, you can say 0x. But 0 times anything is 0. So what really is happening with my x's? They're canceling out. And so when I say 0x, that means I have no x's left in my problem. What parts of my problem is remaining? Negative 2 equals 8. And hopefully you made it down for 2.
Bless you.
Negative 2 does not equal 8 because my variables cancel out and I am left with a false statement. We're going to say what? No solution.
I guess I can return these.
Now, beware, if you had left negative 6x plus 6x to be x, realize if you tell me that's x, you're telling me that is 1x, right? And it's not 1x, it's 0. Are we okay with that one? Okay, we're skipping the next one. We're skipping our P's and Q's. If you want to work it out, I'll tell you it's a no solution as well. I should be making Carter happy there by skipping the P's and Q's. Let's go down to the bottom one.
Oh. No solution.
Okay, very last example on this front page. Negative 3y equals 9x plus 1. 6y equals negative 18x minus 2. Which equation do you want to solve for which variable?
I think we should do the second one for y because then we wouldn't have to divide by 9. There's really no reason behind it, but I just don't want to divide by 9.
Okay. Cyrus says she doesn't want to divide by negative, so she says use the second one and solve for y.
I disagree with everyone else.
Hey, you can do the first one together.
No.
Yeah, you
Okay.
know it's neither.
I'm done.
Either way, you're stuck with a fraction in there, aren't you?
Yeah.
Okay? So either way, we're stuck with a fraction, and we're going to have to make it work. So honestly, it doesn't matter. I don't know. I guess the bottom one you divide by positive. The top one you divide by negative, but there's no reducing. So I guess there's a pro both ways, isn't there? Some of you guys are figuring something else out. So, okay. So do you guys care? I mean, I know Cyrus was one way, Caden was the other way,
No,
but
I'm not going to choose.
No, I'll give it to Kaden on this.
No, don't give it to Cyrus.
I think this is a win today.
well, I'll be honest. In my notes, I have it done with the top one.
Okay.
So,
Do it.
but in all honesty, this is one of these where I could easily go either way. So if we take that top one, how do we solve for y?
Divide by negative 3.
Divide by negative 3. Now, negative 3y divided by negative 3 is y. 9x divided by negative 3. Negative 3x. 1 divided by negative 3. Negative 1/3 or minus 1/3. Please do not go to a decimal there because that's a repeating decimal. And you can't use an exact answer then. Okay, so officially, some of you have already realized what's going to happen. But officially, in the other equation, we're going to substitute this in for y. So it's supposed to be 6y. So we're doing 6 times negative 3x minus 1/3 equals still negative 18x minus 2. Helps if I'm on the screen. Better?
Yeah.
Okay. Just like all of our other problems, we need to distribute. Nice news is when we distribute, my fraction's going to be gone. So it's not a bad fraction. 6 times negative 3x, negative 18x. 6 times negative 1/3, negative 2. 1/3 of 6
Same thing.
is 2, negative 2.
I thought I was doing something wrong.
No, that's what I tried saying, but you didn't listen.
Okay, so now my equation becomes negative 18x minus 2. Again, some of you realize what's happening. Hold your thoughts. Officially, if I try and put my x's on the same side, how do you move a negative 18x?
I'd say
You add 18x. What is negative 18x plus 18x? 0. So we have 0 minus 2, so negative 2 equals 0 minus 2, so negative 2. What just happened?
You got the same thing.
Okay, so the variables canceled out again, just like my no solution problem. However, what's different?
It's true.
It's true.
Negative 2 does equal negative 2. And so instead of saying no solution, this is infinitely many solutions. Some of you saw this in homework on Monday. You would graph one line, and then you'd go to graph the second line, and it was the exact same line. That's infinitely many solutions. Now, some of you also noticed back up here, we solved the top one and got y equals negative 3x minus 1/3. What if Cyrus solved the bottom one? She also got y equals negative 3x minus 1/3 once it was reduced. So there were multiple different places along the way that you would have realized they were the same equation. Yes, Eli?
I've never understood what it means by infinitely many solutions. Like, is that saying that like any point on the line is a solution?
Because, so a solution is where the two lines touch, right? These are the same lines, which means every place along the line they are always touching. Which means, you know, if it goes through 0, 0, that's a solution. If it goes through 1, 1, that's a solution. 2, 2. So because lines go on indefinitely, there's an infinite amount of solutions because there's always more places it's touching. Does that answer it?
Yeah.
Okay. As opposed to what's true when it's no solution? The lines are what? They're parallel, and they're never touching. And that's why we say no solution. Infinite means we could all keep writing down ordered pairs and never be done. There's always be more to find. Okay? Okay, let's look. I think I'm just going to look at the top problem here, and I think that will be good. Now, okay, don't do it to me. It's words. Nope, I don't want to hear those. I don't like words. Step 1 is to read the problem. Okay, you have to read the problem. Okay, so a music store offers piano lessons at a discount for customers buying new pianos. The cost for lessons and a one-time fee are advertised as 6 lessons for $300 or 12 lessons for $480. What is the cost of each lesson and the one-time fee for materials? Okay, I read it. And for some of you, that didn't help any. So, once you read it, go back and break it down. Okay, go back and let's see what we can figure out. A music store offers piano lessons at a discount for customers buying new pianos. Okay, that's just setting the problem up. That doesn't give me anything helpful there. The cost for lessons, so what are we talking about here? Lessons and a one-time fee are advertised. 6 lessons for $300 or 12 lessons for $480. And then we want the cost of each. Now, it doesn't specifically say here, but Monday I let you off the hook on writing equations. Today, we're practicing writing these equations. So, start by asking, what are my unknowns? What are they asking me to find that I need to put variables for? Okay, one-time fee. Do we know the one-time fee? No. So, that's going to be one of our variables. And what else do we need a variable for?
The cost of each lesson.
The question says, what is the cost of each lesson and one-time fee? So make those your variables. Whether you want to use X and Y, A and B, whatever you want. I'm going to pick X and Y. So the cost of each lesson I'm calling X. The one-time fee I'm calling Y. Okay. First scenario said what?
6 lessons, $300.
6 lessons, $300. Now, notice it's the cost for lessons and a one-time fee, or advertised as 6 lessons for $300. So, how much is each lesson? We're going to call it X. How much is the one-time fee?
Y.
Y. And what's that have to equal? 300. So, how do I write that equation? 6x plus y equals 300. 6 lessons, X dollars, plus that one-time fee. That's the part that's easy to overlook in this problem. Okay, second scenario. 12 lessons for $480. So how much are each of those 12 lessons? X. And then what else do we have to include? One-time fee. How much is a one-time fee? Y. So what's my equation?
12x plus y equals 480.
There's your equations. Okay? A quiz or a test, this would be a required part to get the full points. Now, what's the name of my game today? Substitution. Okay? Yes, you can use your calculator, but we're going to substitute to actually get this, as opposed to just guessing and checking, which is what some of you may have already done. So, pick an equation. Which one do you want to solve for what? Yeah. You can pick, obviously we're going to solve for y. Pick whichever one. Going for the top one. So if we solve that top one for y, it becomes y equals what? Okay. Because we're going to subtract the 6x over. So negative 6x plus 300. Whoops. So, in my other equation, every place I see a y, we're going to write that. So, 12x plus, what's my y? Negative 6x plus 300, and this is going to equal 480. Do the math. What's first here? Combine like terms. We don't have to distribute. So what is 12x plus negative 6x? If it's 6x plus 300, we're going to subtract 300. 6x equals 180. Divide by 6, and x is 30. Officially 30 what? Dollars. And what is $30? Okay, because it's x, and we called x my lessons, then I know that each lesson is $30. What else do I need to find? We need to find y. How would you like to find y? Yeah. Plug that 30 back into one of your equations. So I'm going to say y equals negative 6 times 30 plus 300. Negative 6 times 30 is negative 180 plus 300, 120. 120 what? $120. And what is that $120? One-time fee is $120. Yes. Negative 6 times 30 is negative 180. I could have said something wrong. I can't guarantee I said it right, but.
No, I don't think you did. I said my brain count last.
Okay.
He's got a power.
Okay, guys. I don't want to get caught in the middle of anything. I'm going to stop there. You actually have a few minutes. You could jump into the homework and see what it looks like. Now, your homework will be called Lesson 3.2.1. Not to be confused with 3.2.2 that you'll do tomorrow. Okay?
I think this actually make it easier. Last night, there was a problem with this.